Hello Internet! In this video we are going to be working on creating a grass shader. So this is going to be the first step in hopefully multi-part series. Initially we're just going to focus on getting an instanced grass rendered to our scene. And then after we get that working, we're going to work on getting it to like bend out of your way and things, but that's coming later. So just for now, I want something so I can just put a rectangle on my terrain and just have it fill it with grass. So I've been reading up on this. There's two NVIDIA GPU gem, or there's two approaches recommended in the NVIDIA GPU gems article on grass shaders. It looks like this. So I call them the inner intersection and the outer intersection. So this one, they're both made with 3 planes or 3 quads. And this one is just sort of like a triangle shape with the grass on each side. And then this one, the inner intersection, they kind of meet in the middle. So we're gonna play around with those. The alternative is like a billboarded strategy, which is just a plane that always faces the camera. I don't think that looks good, so we're not gonna do that. But I just threw these together. I didn't even pull off the colliders, which would have been smart, or save them as prefabs. So I'm going to do both of that. I'm going to do that now. And then what we need to do, first off, this is broken. This is just using a standard shader, which doesn't exactly do what we need because it doesn't actually draw anything on the back. So we need to do 2 things in this. First, we're going to create a new shader. So I'm just going to do a new standard surface shader. Call it our grass terrain shader, which probably isn't the best name for it. But this is going to create a shader. It's going to be really simple. It's just going to be a cutout shader, which is going to have no culling. So we're going to turn cull off. So all you have to do is do cull off, and that will actually turn off culling for whatever you're rendering. So in this case, our shadow only, or our planes, our original, the standard surface shader only draws on one side or the other. And so what this is doing is this is saying I want to draw both sides. So now both sides of it will render, which is good if we have just a single object. It also works really well for grass too. You'll notice I'm using Unity. I upgraded to Unity 5.6. One of the things they added, I'll go back here. Even in the standard surface shader, there's now this enable instancing. Previously, you need a separate shader for instancing. Now you can just check this box, and this applies to any shader. So that you don't need to make a separate special instance shader. You can just toggle this, which is super handy. I believe that's where this is coming from. I actually haven't done anything with any shaders in this since upgrading, so we'll see. Yeah, that seems like that's what that's doing. So grab that and then clip on C.A. So just clip on our alpha and then we're good. That should be everything I needed to do there. So let's just apply that. And it's going to think about it, and then we get that horribleness. That wasn't really what I wanted. Let's subtract off random arbitrary value. So I'm just going to subtract off a clip value, which I'm just going to say is 0.5. And we'll get that. We can make that configurable, but this isn't really the point of the video. That's easy. We just needed to do that. So you see enable instancing is still there, and it's still checked from the last time, which is good. So what I'm thinking is we're going to define a rectangle, and then we're going to do ray traces down, find where it intersects, and then draw grass at those points. And so just like we did with our asteroid belt render, we can use instance rendering for this. So I have these both as prefabs. So I'm going to delete those and create a new, what are we going to call it? A grass generator. That's probably not the best name for it, but we're going to go with it. Continuing with our trend of really poor project structure, we're going to create a grass renderer. And so the limitation is instance rendering can only render 1,000 objects at once, which should be plenty. That shouldn't be an issue. But if it is, then you'll need multiple of these. So something to keep in mind. What is going on? Why? There we go. Everything came back. So I think we're good. So the first thing, I'm going to make this execute in edit mode so we can move this around and the grass will be constantly generated. That just seems like the best way to do this because I don't really want to do that. And some of these things, I'm going to cut a few corners here. This isn't going to be an asset you can pull into your game and just use. I'm going to kind of demonstrate the style, but I'm going to do that in a way where it's constantly regenerating it every update. You'll probably want to move that up to like start or something, but just for what we're doing, it makes sense to actually regenerate it every time. And by doing that, we're actually going to be able to more closely control how this actually looks and actually test it a little bit better. So I'm going to give it a width and a height. We could have used, let's actually use a vector 2 here. We'll call it like our size. That seems good. And then we already have the position. That's just our object's transform. We're going to need a number of grasses. So int grass number. Remember, this can only be between 1 and 1,000, so I'm going to limit that. Just plug in a range here between 1 and 1,000. And why are you... There we go. So we have the size of our rectangle. We have the grass. Public float start height. So this is going to be the start height of where our rays are cast from. I'm just going to initialize it to some big number. So if you will like at the top of mountains, for example, I don't know why you'd be doing this across an entire terrain, but if you're at the top of a mountain and you want it to not draw above a certain height, you can use this, and the rays will start at that height, so they won't hit anything if they don't, if they're below the terrain, so you'll be good. I'm not sure if that makes any sense, but we're going to do it anyway. Start. Don't need anything there. Like I said, we're going to try to do this all in our update, just so we get it constantly doing that. So one of the things I'm going to do is I'm actually going to seed this. So we're going to seed it with our X, Y, and Z, or just our X and Z actually. The Y isn't really going to change. So we are going to plug in the grass number. So as we change that, it will actually move things around. Actually, there's a better way to do this. Public int seed. There we go. And so the reason I'm doing this is because now that we've reset our random numbers in computer programs aren't actually random. They're pseudo-random, which means there is some algorithm that is going to constantly pick a number. And effectively what it does is it uses the result from the last time it ran to calculate the next one. And so it just keeps going. And there's mathematical formulas to prove that it's relatively random. But what we're doing here is we're setting it to a hard value, which means every single time we call this, that next value is going to be exactly the same. So this will actually always get us consistent results, even though we're calling a random function. So since we're doing that, we need to iterate over this for our grass number. So iterate over the number of grasses and actually generate what they should do. And then we're going to need a graphics dot in draw mesh instanced. They did add a new draw mesh instanced indirect. I don't know what that does. we'll have to explore that later. But for now, we just need this. So we can give it a mesh, a submesh, material, and then the matrices. So I'm going to need the public mesh, grass mesh, and the public material for our material. And so we'll just plug in our grass. Oops. Why can't I type? There we go. That was being weird. I couldn't type my M for some reason. And then we're going to have our matrices, which we don't have at this moment, but we are going to make those. So I'm going to create a list of matrix 4x4s. Let's make this a linked list because let's not actually, because I can initialize this. So if we do a matrices equals a new list of grass number. So what I'm doing here is I'm actually initializing a array list to a specific size, specifically the grass number. And because I'm doing that, it should prevent it from actually needing to grow as we add things to it, which means our inserts should be constant. So ideally, it speeds things up. I don't know how C# is handling this on the back end, but that's sort of how that works. It gets a little bit funky because there's a bunch of other stuff that has to happen for that to work, but I'm going to assume that it's going to happen. Sorry, my camera's being super weird, but we'll carry on. Did I spell matrices right? I don't think I did. I think this is wrong. We're gonna continue anyway. So, the first thing actually before I get into that, we need a vector3 origin. And so we need to find a point within our rectangle. So dot position. We want to set the origin dot y equal to our start height. So this is effectively going to be the origin of the ray. We're going to cast it straight down. If we hit something, we're going to draw grass. If we didn't, we're going to ignore it. And that doesn't mean we're going to ignore that and draw it somewhere else. We're going to completely ignore it. And that way, if some of the stuff is below the terrain, it doesn't suddenly randomly get denser, because that doesn't really make any sense. It just won't draw it. So we need to set our x equal to actually, let's do a plus equals of our size.x times the random range, actually, of size.x divided by 2 and size.x divided by 2, which isn't quite right. Do I want to do that? Or could I just do... Yeah, let's just do this. 0.5 and 0.5. F and F. Make them floats. And then multiply it by the size. So we'll get half of the size in either direction. And then we can do that again for the Z. Ooh, turn the wrong thing on. There we go. Size.y. There we go. Sorry about that. So this gets us a origin point way off into the ceiling, wherever our start height is. And then we want to cast it straight down. So do ray equals new, create a new ray, add our origin, which we already have. And then we just need to do vector3.down to cast it straight down. Then we're going to need a raycast hit. So we're going to take the hit value, and then if our physics.raycast hits anything, so if we do ray, max distance, do I care? Yeah, we want out hit. So if we hit anything, then we want to add our matrices. Otherwise, we're just ignoring it. We're done. So if we hit something, then our origin is going to equal the hit dot point. So that's going to be the point wherever it hit on world space. So we're casting this straight down. We're going to eventually hit like the ground, hopefully. I'm hoping to test this against a terrain and make sure it actually works. We may want to insert like a mask or something here, so like it doesn't hit rocks and draw on top of rocks, but that's something you can add yourself. Then what we need, now that we have effectively an origin where we want to spawn this, everything else for now we can keep the same. So 4x4 dot TRS, which is translate rotation scale. Translation, rotation, and scale. So we want the origin to equal the position. We'll use the identity quaternion, which will be just 0, 0, 0 in Euler coordinates. And then vector 3 dot 1, which will just be a completely unscaled thing. So it'll be however big it is in the prefab. Then we should be good. That should draw everything we need. Unless I'm very much mistaken. So if I bring that over there, drop our material and our, it's expecting a mesh. These aren't meshes. I may have gotten ahead of myself here. So yeah, I don't know how we can, I mean, I could go into Blender and make these super quickly, but I don't really want to. What if I just do quads? This will at least show us if it works. I can go into Blender and pull out some quick samples afterwards, but then the size, we'll do 5 and 5. That's going to be really dense. Let's do 30 and 30. So you shouldn't see anything because it's not going to actually collide with anything yet. And we should be done getting those. So I should be able to stick a plane in here though. And I would have expected it to show things. Well, that's unfortunate. Oh, grass number 0. There we go. So now I can increase this. We're getting, the shadows are wrong, but we have 1,000 of these grass tufts. But this is too big. So if I shrink this down a bunch and lower our plane because it's a little too high. Oh, it's not too high. Our grass is, got it. How can we fix this? This is a gross way to fix it. It works though, so I'm going to remove the mesh renderer from this. This is the reason we're having to do this is because we're having to do this because I screwed up and we don't actually have the mesh that we need to do this with the proper thing. So we're getting some weird things. There are some funky shadows going on here. And I don't know what that is on top. There's some sort of artifacting going on as well. Cool news. It works. And it dynamically is able to like draw it. So as I move this, it's actually drawing it underneath the thing, which is neat. But it's doing it a bit weirdly. What if we bring out a terrain Yeah, the shadows are all kinds of messed up. I think I need to actually make a proper cutout shader. The way I did it was sort of a hack. We can do better. There's actually an actual cutout thing. So for the next video, I'll probably pull that in. But for now, we're just going to get that. I can actually slightly improve this, I think. Not like that. 0 point. There we go. So that's also a hack, but it sort of improves it at least, so it looks right. Just cheats, but you get the idea. So, grass. We have grass, and it's actually, I'm assuming it's running fairly quickly, because it should all be one draw call. So yeah, even with that, we're getting 200 frames a second, and I can increase that to a lot. So we've got 5,000 unique drawn grass things, and it looks super dense, as you can tell. So I don't think you're going to run into too many performance issues, and then most of this performance, all of this impact is coming from regenerating all of this every single frame. We're recalculating all 5,000 positions every frame. That's where our performance hit is coming from. I don't think it's coming from the rendering. Yeah. We're taking a big CPU hit and not much for rendering, which is good. It means this actually really isn't that much of a problem. So theoretically, we can expand this. This is sort of where I wanted to be though. I just wanted to prove a little bit to myself and a little bit to everybody else that you can actually, oh, okay. That looks awful. Excuse that. But you can actually like modify the terrain and it still matches. So we can also, well, that's not gonna help. Reduce this to like say 10. And you can actually get like that cutoff. So if you have like a mountain peak here, you can actually cut that off and there'll be grass below it, but not on top. So hopefully it seems simple enough. For the amount of time we spent on it, it looks really well. The shadows are gonna bug me, but I think we can fix that with a proper cutout shader. And if we pull in an actual mesh from Blender, we'll fix the fact that they're all getting cut off. But the randomness of it seems good because it kind of, from the proper direction, it looks fairly random, which is good. It's what we were going for. So every time you get what you want, that's usually a good sign. And it even if we're doing it all at once, it's actually fairly responsive. So yeah, we'll build this out. If you've got any ideas on what we could do with this, I know I did get a request to actually make it so it would bend, like grass would bend out of your way and things. So that's sort of where I want to take this. But if there's any other like grass rendering or whatever you want to do, I've seen people do grass with fur before. We may want to try that because I think that could be really cool. Especially I think if you mixed both of them. So if you had like bushes and stuff rendered with this, and then you had the standard like fur for the normal terrain, I think combining those would look really sweet. So with that may be where we're headed. I'm not entirely sure, but it seems like it could be promising. So yeah, that's it for now. If there's anything else you guys want to see, any other ideas you have that or things you want to learn, I guess, let me know, because that's how I get my ideas. If there's anything you want me to improve on or anything you want me to change, I'd love to hear that too. That's how I get better. So yeah, until next time, see you, Internet.